My dear students, welcome back to our channel. In this video, I will be explaining the MBA second semester subject Operation Research as prescribed by Osmania University, Palamuru University and other universities of Telangana. We will go through the important case studies with questions and answers one by one. Let's begin with a quick revision. Part C. Case study 10 marks. Jain Clothing Stores. Mr. Vipin Jain, owner of clothing stores, is planning annual sale of shirts and pants. Mr. Jain is planning to use two different forms of advertising, viz. Radio and newspaper ads, in order to promote the sale. Based on past experience, Mr. Jain feels confident that each newspaper advertisement will reach 40,000 shirt customers and 80,000 pant customers. Each radio advertisement, he believes, will reach 30,000 shirt customers and 20,000 pant customers. The cost of each newspaper advertisement is 30,000 rupees and the cost of each radio spot is 45,000 rupees. The advertising agency will prepare the advertisements and it will require 5 man-hours of preparation for each newspaper advertisement and 15 man-hours of preparation for each radio spot. Mr. Jain's sales manager says that a minimum of 75 man-hours should be spent on preparation of advertising in order to fully utilize the services of advertising agency. Mr. Jain feels that in order to have a successful sale, the advertising must reach at least 3,60,000 shirt customers and at least 4 lakhs pant customers. You as newly appointed management trainee are expected to suggest the media planning for advertisement at a minimum cost and still attain the objective of Mr. Jain. Case study: Jain Clothing Stores, Optimal Media Planning. Problem summary. Mr. Vipin Jain owns a clothing store and wants to promote a sale using two types of advertisements: newspaper ads, radio ads. Each ad type reaches different numbers of customers for shirts and pants, costs different amounts and needs preparation time. Let's define the variables. Let X is equal to number of newspaper ads. Y is equal to number of radio ads. Objective: minimize total cost of advertising. Cost is equal to 30,000 rupee per newspaper ad and 45,000 rupee per radio ad. So, minimize Z is equal to 30,000 X plus 45,000 Y. Constraints. From the case, we get 3 conditions. 1. Shirt customer reach. Each newspaper ad reaches 40,000 shirt customers and radio reaches 30,000. So, 40,000 X plus 30,000 Y greater than or equal to 3,60,000 4 X plus 3 Y greater than or equal to 36. 2. Pant customer reach. Each newspaper ad reaches 80,000 pant customers and radio reaches 20,000. So, 80,000 X plus 20,000 Y greater than or equal to 4 lakhs 8 X plus 2 Y greater than or equal to 40. 3 man-hours for preparation. 5 hours for newspaper, 15 hours for radio. Minimum 75 hours needed. 5x plus 15 y greater than or equal to 75. Also, x greater than or equal to 0, y greater than or equal to 0. Linear programming model. Minimize. Z is equal to 30,000 x plus 45,000 y. Subject to 4x plus 3y greater than or equal to 36. 8x plus 2y greater than or equal to 40. 5x plus 15y greater than or equal to 75. X, y greater than or equal to 0. Conclusion. This is a linear programming problem. We can solve it using graphical method, since there are two variables, or software tools like Excel Solver or Tora. Mr. Jain should use this model to find the optimal number of newspaper and radio ads that reach both shirt and pant customers. Use the minimum preparation time. Minimize the total cost. This helps in effective media planning with maximum reach and minimum cost. Next, Case Study 1, Linear Programming in Production Planning. Case: a small factory produces two products, A and B. Each unit of product A requires 2 hours of machining and 3 hours of labor. Product B needs 3 hours of machining and 2 hours of labor. The factory has a total of 120 hours of machine time and 150 hours of labor available. The profit is 60 rupees on product A and 50 rupees on product B. The manager wants to decide how many units of A and B to produce to maximize profit. Questions and answers. 1. Formulate the problem as an LPE. Maximize Z is equal to 60A plus 50B. Subject to 2A plus 3B less than or equal to 120 machine time. 3A plus 2B less than or equal to 150 labor. A, B greater than or equal to 0. 2. What is the objective of the problem? To maximize total profit. 3. Can this be solved using graphical method? Yes, because it involves two variables, A and B. Next, Case Study 2, Transportation Problem for Delivery Optimization. Case: a logistics company has two warehouse, W1, W2, and 3 retail stores, R1, R2, R3. Supply from W1 is 100 units and W2 is 150 units. Demands are R1 80 units, R2 120 units, R3 50 units. Transportation cost per unit is as follows. R1, R2, R3. W1 468. W2 537. Questions and answers. 1. Which OR model is used here? Transportation problem. 2. Is the problem balanced? Yes. Total supply is equal to total demand is equal to 250 units. 3. What is the aim? To minimize transportation cost. Next, Case Study 3, Network Model in Project Scheduling. Case: a construction project has 5 activities. The project manager prepares a network using CPM. Activity durations in days A, 3, B, 5, C, 4, D, 2, E, 6. Activities A and B start the project. C follows A, D follows B, E follows both C and D. Questions and answers. 1. What is the first step in CPM? Drawing the project network. 2. How is the critical path determined? By calculating earliest start, ES, and latest finish, LF, for each activity. 3. Why is critical path important? It shows the longest duration path and helps avoid delays. Next, Case Study 4, Game Theory in Business Strategy. Case: a telecom company launches a new plan. It expects a response from its competitor. The payoff matrix, profit in lakhs, is Comp A, cut price Comp A, no change. RCO, cut price 3,372. RCO, no change 2,755. Questions and answers. 1. Which OR concept is used? Gain theory 2% zero-sum game. 2. Is there a saddle point? Yes, 5, 5 is a stable outcome. 3. What should our company do? Choose no change strategy for maximum safe payoff. Case Study 5, Queuing Theory at a Bank Counter. Case: A bank has one service counter. On average, 10 customers arrive per hour, Poisson arrival. It takes 5 minutes to serve one customer, exponential service rate. Management wants to check average waiting time. Questions and answers. 1. Which model is used here? Single channel, Poisson exponential queuing model. 2. What is arrival rate, lambda? 10 per hour. 3. What is service rate, mu? 12 per hour, since 60 divided by 5 equals 12. 4. Is the system stable? Yes, since lambda mu.